It's a pleasure for me to introduce to you Mr. Stefan Priebsch, who is one of the co-founders of the PHP.cc, the PHP Consulting Company, a colleague of Mr. Sebastian Bergman. They're working together on helping software teams achieve better quality on their work, and he's also a proven scalability expert because he's a father of twins. So, your applause for Mr. Stefan Priebsch, please.
Thanks. I'll skip my introduction and cut right to the chase so we can save time. Time is rather limited. Can I get a show of hands? Who is familiar with the term being Rasmused? Okay, being Rasmused, you know who Rasmus is, right? Rasmus Lerdorf is like the original founder of PHP. The term being Rasmused refers to a conference is going on, you have multiple tracks, and somebody gets virtually no attendees because you have Rasmus speaking in the other room. Are you aware of the fact that there is another presentation going on next? I really appreciate everybody being here. So Michelangelo has shared so many insights, and Sebastian did. Here's my little piece of advice. Don't be scared to get out there and start speaking. First time I ever spoke at a conference, I actually Rasmused Zev Suraski. I got like 80 attendees, and he got like 10. And first time I ever spoke at an international conference, I think that was ZendCon whenever, I was being Rasmused by Yahoo throwing a party the night before, and I had the first slot, so basically I had nobody show up. Can happen to anybody, and it really, really depends on a lot of circumstances, right? Okay, we'll skip that. I'm the guy who gets randomly quoted in other people's presentations, and we'll cut right to the chase. I did that presentation before at a user group in Munich, which originally sort of brought material from two presentations I had given before together. And as I was listening to Michelangelo's keynote and Sebastian's talk earlier today, I figured that the presentation is not right for the conference, so I rewrote it. And I typed the code examples right there into the presentation, and I'm sure I have left a few syntax errors for you to discover. So who is familiar with the term or the concept of MVC? Okay, I mean, that's pretty much everybody. And you all have seen that. By the way, that's wrong, because they have one arrow pointing in the wrong direction, but I'm completely incapable of using graphics software, so I tend to steal those things from the net somewhere. This is what MVC is all about, and I'm going to make that very, very short, right? It's a UI pattern, and its purpose is you have a UI, you have the same information in multiple places in different visual representations, right? So that number there, the revenue, you have it up here, and you have it, well, it's probably that one, right? How are you going to implement code that makes sure that those multiple views on the same data keep in sync? This is what MVC back in the 70s was originally designed for. Now, I like to quote Martin Fowler, and he's a bit confused about people using MVC as a UI pattern. And he says, well, basically, I don't know what people are doing, but sometimes it may even be MVC. The problem, and he is talking about UI patterns, the problem with writing PHP software for the web, that's not the UI you are writing. Okay, so MVC on the web, that's really a whole different story, because if we go back to this, the meaning of that is, okay, we have a controller that observes the view. The view is a GUI component, and if somebody changes data there, the controller gets notified and makes a decision to update the model, which is that error right here, and the model then is being observed by the view, and the view pulls data from the model, because the model has said the views, hey, I've changed, so the views pull the state from the model. That's very, very short, and I'm sure you all have heard that. The cool thing is it totally does not apply to the web, right? Because on the web, the view is remote. We have a system boundary right here. So all those two subject-observer relationships from a technology point of view don't work in the first place. But the good news is, the problem that MVC solves, which is synchronizing multiple views on the same data, we don't have that problem in the first place. No web application has this problem, because you're just creating one page. So, without going into depth, this is what you have to ask your favorite search engine for. I have given a bunch of presentations on that topic, and if you're interested in finding out more, this is what you need to search for, and it's going to come up with a bunch of material and presentations. I think 2 or 3 years ago, I gave a keynote at some conference where I had actually written an MVC play and had people on stage to act out MVC as a pattern, and there's a video on that on the web. So if you're interested, you can find that and have a look at that. So who's familiar with the term solid? Okay. So schoolbook definition of solid, drawn from Wikipedia, as all good developers draw their schoolbook definitions from. Basically, if you stick to a couple of principles, solid is an acronym, right? It represents 5 principles. If you stick to those 5 principles, your code is going to be maintainable. Which implies that if you do not stick to solid, your code is not going to be maintainable. And this is a big problem for a lot of teams and companies dealing with outrageous numbers of lines of legacy code. It's not maintainable. And mind you, there is a difference between maintainable and extensible, right? Extensible means I can add new functionality. That's relatively easy to do, even with crappy code, because you can always do that in a decent fashion. Not a lot of people do, but you could. Changing it is harder. If your company's business changes, you need to adapt code to changing business needs, and the code is hard to maintain. It's hard to change. That's a bad position to be in, and we all know that. And my presentation is going to be about trying to point you at some things that people tend to get wrong in current MVC type of setups, and give you some ideas of how I think you could do things better, and then leave you with a lot of room for thought. And I'll be around till tomorrow in the afternoon. So if you have any additional questions, if you want to have a discussion, if you want to have a chat, drop me a line or just find me as I walk the grounds. The SOLID acronym basically goes back to this book, Bertrand Meyer, Object-Oriented Software Construction, that's been published in 1983, I believe. Don't read that book. It's impossible to read. I think he's a professor. I think he has a mathematician background, and he manages to come up with formulas and stuff that no sane person can understand. Maybe that is why Michael Feathers and Robert C. Martin, Uncle Bob, have sort of come up with the SOLID acronym. And the principles go back to 1983, so everything has already been there then. And us developers did a really great job in forgetting all that. So we have to relearn. SOLID, those are the 5 principles. I'll just go over them briefly. The focus of this talk is to see how those principles apply to MVC, or where things that we commonly do violate those principles. And if you want to dig into those principles, it's going to take you quite some time to get warm with some of the principles. So single responsibility is pretty simple. It sort of ties into separation of concerns. Have one class do one thing. It sounds so simple, right? Another way of looking at that is, how many reasons are there to change a piece of code? If there are 2 different reasons, obviously the code has 2 responsibilities. And if you separate them, you get closer to a design where, well, if I change this, this is the piece of code that I have to touch. If I change that, I have to touch another piece of code. But I'm limiting the possibility of side effects happening. The open-closed principle originally refers pretty much to compiled environments where you have a large monolithic binary end up on the server. And you don't want to give companies that have bought your software potentially the possibility to compile the software. So how could they possibly get extensions or adaptations into the software? So you need a kind of plug-in mechanism. And this is basically what open-close principle in essence states. You need this to be extensible. You don't want to recompile 10 million lines of code if you add one, right? With PHP, we don't really have that problem. That's one of the cool things about PHP. Still, we can apply the open-closed principle in a bit of a different way and look at how can we extend classes and how can we write code so in a way that it's easy and safe to extend classes, and how can we prevent people from screwing up as they extend our own classes. We'll touch upon that a bit later. Liskov substitution principle, I think, is the most complicated one to really understand. Sometimes I'm not sure whether I have really fully understand it. The way I interpret it is in short, inheritance sucks. Okay? So there is a lot of problems potentially associated with the concept of inheritance. In fact, some people say you don't need inheritance. Some strict OOP proponents say, well, you just should extend from an abstract base class and never anything else. Whether you want to be that religious or not, sometimes it makes sense. Inheritance is a problematic concept. So what Liskov states basically is, if you write a class and you extend it, then the subclass must be substitutable for the base class. So you can't have less functionality. That also means you can't have new return types or new return values. So imagine you have a class that does something and it never throws an exception. Never does. Now you create a subclass, and this subclass throws an exception in a certain case. That's extending the API. That's an additional return value. And the code working with the subclass will not expect this exception because it was not part of the original contract with the class he was working with. So weird things might happen because the code calling that doesn't know how to deal with that exception. So that's a very, very short and concise attempt at explaining the Liskov substitution principle. Interface segregation, that's a very interesting one. Clients should not be forced to depend upon interfaces that they do not use. That sort of translates into make your interfaces small. We'll get to that. Dependency inversion, to me that's the most interesting and most important principle, and it's the least understood, I think. A lot of people say, okay, dependency inversion basically means dependency injection. Nope, that's not true. You will need dependency injection to achieve dependency inversion, but there's a lot more to dependency inversion. So the text is, let's look at something in drawing, right? Dependency inversion says this is a problem. You have your domain or your application, and that depends on some infrastructure. You may think this is natural, but it's a problem, because now if the infrastructure changes, we have to make sure that our code still works, and that's a problem. And dependency inversion says, how about inverting that dependency? How about reverting the direction of the arrow? If we can do that, that would be awesome, because then our domain wouldn't even know that infrastructure exists. Thus, if we change the infrastructure, there is no way that could possibly influence our domain, the core of our application. And it turns out, and again, this is a very, very short and concise explanation, it turns out you can achieve this by defining an interface as part of your domain, defining an infrastructure, and write an adapter that becomes part of the infrastructure that implements that interface. Suddenly, your domain does not know about the infrastructure anymore, but your infrastructure has a dependency on the domain. That's kind of cool. And we're going to have a code example for that later. So let's dig into code, right? We are developers here. We want to look at code. Who has seen code like that? Okay. What is the problem with that? How many solid principles are we potentially violating? Up to 5, that's a good one. Thank you. I haven't thought of that one. So it turns out that if you violate one of the solid principles, you probably also violate others. Single responsibility. How many reasons are there to change this controller? Well, if the creation needs to be done differently, that's one reason to change it. If deletion needs to be changed, that's another reason. And if index action, and honestly, I don't know what the fuck index action, how that relates to your business, but anyway, we have it. So if we need to change that, that's a third reason. So that's not single responsibility. We are also violating dependency inversion, because this is your code and it depends on a framework. A framework is infrastructure. And as I said, inheritance is a problem. We are not really violating Liskov here, but there are some pointers at this may be smelly. You know about the term of code smells. Everybody who has children knows at some point there is smell. And if there is smell, you know, the small children, if there is smell, you need to change diapers. And as Kent Beck wrote the book on refactoring, he was looking for a term and said, okay, Grandma Beck told him with regards to his baby, if it smells, change the diapers. And he felt like, looking at code and it's kind of smelly. So maybe something is wrong, right? So that's a code smell. And that's the solution. Break it down. Single responsibility. Have one action in each controller. We can take this further. Well, looking at that, why would we have to name that index action and that create action if we have one action method in each controller in the first place? So we might actually have a common name for that, which would put us into the position of defining an interface. Now, this interface is not really meaningful to whatever you guys are doing, because if you talk to your customers, I'm sure that unless they are an accounting company, they really have no clue what a controller is. And, well, yeah, I'm running the controller is like, okay. You're executing code. Okay, you do that all day. So that really doesn't give me any information. So we might need to reconsider that name. Turns out that, well, maybe it's about processing an HTTP request, right? That's usually what the controller should do. It receives an HTTP request. It's sort of pretty far on the front end. And technically, it does input mapping. It converts the HTTP request to something which may be another type of request or just a method call on some business object. Some people like to call it a model that your application or domain can deal with. So technically, controllers are input mappers. With regards to single responsibility, that's a very interesting observation. Because if a controller is an input mapper, then the only thing a controller is allowed to do is input mapping. Everything else violates solid and will get you into a maintenance problem at some point in the future. Now, once we have arrived at that, we might even take it a bit further and say, okay, we can have a decent interface for that, but you know what? There is that distinction between reading and writing that people care far too less about, CQRS or command query separation, that goes back to Bertrand Meyer again, are terms that you need to look at to understand what the value of the separation is. In essence, is either you're retrieving information, like a getter, or you're changing state. It's like a setter or a mutator. And if you do either, it really has nothing to do with the other. So we might want to be able to distinguish between a GET and a POST request if we build websites. If we build APIs, there's other request types that we might need to look at, and maybe we want to have a read request or write request abstraction. But imagine, let me put it the other way around. Who has ever encountered a problem with somebody views a page, and that page does cause a side effect, changes the state of the application, and weird things happen that are unexpected? Who's ever encountered that? Okay, few. So, to you guys, are you aware that this solves your problem? This makes it impossible for this problem to occur in the first place. Because if you have code that does, like index, whatever that may be, and does the creation, index is probably retrieval of information, right? It's a GET request. And this is a request that changes state. If you start separating that more clearly, you arrive at single responsibility again. You don't write controllers that say, oh, if it's a POST request, then I'm going to process the form. If it's a GET request, I'm going to display the form. So you're putting two different responsibilities in one class, again, violating single responsibility principle. That leaves me unhappy with the controller thing, because that's not a controller. Maybe it should be an input mapper. Let's talk about interface segregation. Now, this is typically methods, and don't ask me why I put get factory in there twice, to stress the point probably. This is an API that your framework controller would probably have. Now you're saying, well, it's not a public API, so we are safe. It doesn't cause a problem. Yes, it does. So with a public API, it's like, okay, you have a public API, people use it, and I can't prevent people from using it since it's public, and it's bad, they can do weird things. Well, with a protected API, that's internal to the inheritance tree. And if all your controllers extend the framework controllers, that's the API they are bound to. Now, does the code that you put into the controller need those methods? If yes, then your controller is doing too much. We'll get to that in a minute. If no, then why the hell would you inherit from a framework controller that has a bunch of stuff that you don't need? Because if you do that, you have a tight coupling, violating dependency inversion principle. And that means if the base class of the framework changes because they figured, oh, we are not going to have the service container injected in every controller because somebody has ultimately made it clear to us that it's a stupid idea, then you have a problem because you have to fix all your code that's based on this controller. And this is the maintenance problem. And this is just one way of highlighting or trying to highlight. If you're not sticking to the solid rules, if you violate them, this is what causes maintenance trouble. We are not talking about, oh, you're going to die and your software is going to crash forever. It's just those small little things that add up to make your software a maintenance nightmare ultimately, and we want to avoid that. This is from the Symfony, from the official Symfony documentation. I could take probably any other framework because they pretty much all do the same. And they suggest, for convenience reasons, you know, if you need any service, what the hell is a service? Yeah, basically everything. So if you need anything, you can make everything a service, right? If you need anything, you just get it as you need it. Now that's bad. That again violates dependency inversion because you're depending on something that's outside, which is or maybe infrastructure. The problem is that you don't even know what you depend on because it's just strings. Your IDE can't tell. You can't have a decent return type for this get method. How could your IDE possibly help you with auto-completion or telling you if you will retrieve the templating thing and you call a render view method on that, will that method be there with a given signature or not? I can't say. So that's a problem. That's not good. Conceptually, it's this, what you're doing. It's pulling in dependencies. You're not even using dependency injection. And mind you, it's not dependency injection to inject the service container, right? Technically, it's dependency injection, but it defeats the purpose. Because this is a phone book. I'm asking you for your phone number, and you're giving me a whole phone book. You can find out about everything. So from a coupling point of view, from a dependency point of view, your controllers are going to depend on, you don't know, can be anything. That's a maintenance nightmare. So it would be better to have it, well, that's technically what they do, right? Retrieve something from the DI container, have it create for us. It would be better if instead of that implicit API, we would create an explicit API where we have one method for each type that we get from the container. Bless you. So we can have a return value for each of the methods. So your IDE helps you with auto-completion. That's a lot better. It's less flexible, of course, because for every new service that you introduce, you'll have to write a new method. And this is why frameworks suggested that way. They want to help you. We don't know what services you're going to have, so whatever for services you're going to create and put in there, you will be able to work with. You make up your mind whether you really need those generic concepts, right? So the good solution for that would be this. If you need something, I give you something. You don't need the phone book, where you can also retrieve something else, a pile of crap and stuff that you don't want to use. Beautiful class names, right? But you want to retrieve something. Okay. That's what I call dependency disguise. It's hiding away the fact that your class has dependencies. Those dependencies are implicit, they do not show up in the API. This dependency is explicit, it does show up in the API. And that's dependency injection used to achieve the whole thing. So, you know where the problem comes from? There. That's where the problem comes from. You have a number of action methods, and each of these action methods, because they are really unrelated, they do completely different stuff, so each of these methods has a bunch of dependencies. Now, if you want to use dependency injection, you would have to build all those dependencies and inject them, which would give you a constructor with pretty much 70 arguments. That looks ugly. And you have to instantiate 70 objects, but we're pretty sure that we're only going to execute one action method in a request. So we're going to probably throw away 65 of those objects at the end of the request, and we have just instantiated them for nothing. If you break down your controllers to single action ones, you don't have that problem anymore. Because now you don't have one controller with 70 constructor parameters, but you have 10 with 7 each. And that's doable. So this is the wrong attempt of fixing the problem of violating the single responsibility principle in the first place. And this is why not sticking to those principles is so dangerous, because it makes you work around issues that, first of all, do not contribute to you solving the problem, and second, get you in an area where you at some point are forced to do things that you really don't want to be doing. Okay. Let's expand on that even a bit. With regards to the dependency inversion, I promised you a code example. This is it, right? So I have code, maybe a controller, maybe something else, and this has an external dependency on some part of the framework. We do that all day. And that's bad. Now you're going to say, well, that's not a problem because that's an interface, right? And it's loose coupling, so everything is okay. No, it's not. Because you are still depending on an interface that somebody else has defined and is in control of. This interface has the release and change cycles of your framework or whatever component you're using. And those will not align with your business goals. They never do. So, even if it's an interface defined by the framework, it doesn't help you. It's still the wrong direction of dependency. You need to be in charge of that interface, because then you control when it changes. So it's vital that you define the interfaces. It's not only about code against interfaces, it's about being in charge of the interfaces. Because we all know interfaces is what it's all about. You know, people talk to each other, that's an interface. Let's run an example, right? You want to load something, and you have that shiny, great piece of code, component, whatever, ORM mapper, magic thing that does everything with the database you ever wanted, but unfortunately doesn't know about your somethings, whatever that may be. So you're defining the interface as part of your domain, as part of your application, and this is what you are in charge about, and you know what the something is. And this is how you build the adapter. So you can inject your framework, magic, whatever thing, and just use it, and map that back to a something collection that you return, and then it's your loader implementing that interface that you're in charge of. So if you, from a business perspective, need to change that interface, somebody needs to touch that adapter. If the framework component or whatever thing you're using changes, or you want to swap that out for something else, this is what you need to adapt. Literally, the adapter. Adapt the adapter. Great sentence, right? And that's it. Now you have achieved dependency inversion. Your adapter, implementing the interface, everything bright and shiny. Okay, I have a bunch of things that I would like to skip code-wise and run a bit of summary and give you some hints and some tips as to best practices. So in essence, MVC does not really apply to the problem because it synchronizes views. Still, people have taken it to the web and sort of built a structure that is not an architecture, that is not an application architecture. It's just a UI pattern that some people perceive being an application architecture or a substitute for that. It's a part of that, but it's not the whole thing. Without a front controller, MVC doesn't work. So MVC alone doesn't solve any problem. You don't have the problem MVC solves, and the problem is that your framework did not really tell you what the controller and what the model and what the view are meant to be and meant to do in the first place. For the view, everybody agrees. For the question, do I put this into the controller or into the model? Not everybody agrees. For the question, what is the model in the first place? Not everybody agrees. So here's a game that I play. Whenever I talk to a team about MVC, I give them little sticky notes, 3 each, and I say, okay, take 5 minutes, everybody writes down their definition of view, model, and controller. And then we're going to stick that up to the wall and see how it clusters. It never does, right? So the team never agrees on what the hell is that MVC in the first place. Now here's my question. How could you possibly write decent software if what people perceive as the core of their architecture, namely MVC, is unclear to the team, and they have not agreed on, you know, this is what goes into the controller, that is what goes into the model, or maybe that whole MVC idea is just pointless in the first place and we should do something different? Because we're delivering pages all day and only thing MVC doesn't have is a page? How stupid is that? You're building pages, but the most important concept doesn't exist in code. Great. Yes. How do I build a page? Well, a page comprises of controllers that I need to execute. Sorry, doesn't compute with me. Right. So, the only people responsible for the quality of the code that you write is you yourself. You know why? Because on the long run, whatever open source building blocks you may be using, you will inherit them. Because at some point, nobody will maintain them anymore. And it's going to be up to you to maintain them. Or you go, oh, I have to upgrade. Ask people using Magento on how they're planning to upgrade. Ask people about their experience upgrading Symfony 1 to Symfony 2. Or Symfony 2 to 2.1 for that matter. Ask people how they upgraded their Zen Framework 1 application to Zen Framework 2. It's just not possible. And it's not possible because people have violated the solid principles. This is where it all ties back together. So here are a few pointers to look for. If you first make the decision which framework to use, your focus is technology and infrastructure and not the business. Focus on the business problem first. Write business objects, write domain. Look into domain-driven design. Look at the use cases first. Keep them independent from technology. Because technology is pointless. It's about the business, right? Figure out the business and get straight about the business. Because business has a hard time in giving you requirements. We all know that. So one way of dealing with that more efficiently is do not create 10,000 lines of code to deploy software so that business can tell you, oops, that's not the application I wanted. Find means of getting earlier feedback, and you can do that by writing down your business rules in an executable specification, which technically means test-driven development. look into the material of the tutorial Sebastian and I gave yesterday that basically has all that in it. Do we have that online yet? No, okay. If you put code into the framework, you're violating dependency injection. Okay? Write your code and use the framework. What is a framework and what is a component? Get clear on that. Do the sticky notes thing with your team and get clear on the term framework. Technically, framework is an inversion of control container that takes you to the request cycle. Everything else is components. You don't need to use a framework if just what you need is using some components because you don't want to write everything from scratch. I totally agree with that. If you consider migrating from one framework to another, you are doing it wrong. Because the question that you have to ask is, how do I migrate my code that I have accidentally put into the framework? How do I migrate this code out of the framework? And then I can use any other framework. But you will never, ever consider migrating from one framework to another if you do the solid thing, right? It's not about not using frameworks. It's about using frameworks the right way. If your methods do not fit on one screen, they do too much, period. If you don't understand in 30 seconds what a method does, the code is bad, period. That should be your rules. If you're unsure in an MVC setup whether something goes into the controller or the model, another warning sign. Okay. If you have a hard time naming classes and methods, that's the first warning sign, right? You're not clear on what you are doing. If you can't find a clear and concise name for something, I bet it violates at least single responsibility because it does too much. It does so many things, I could never possibly come up with one term describing what it does. Hello? There you go. I think we have time for a bunch of questions. Thanks for listening. Thanks for attending. Enjoy the rest of the conference.
So guys, questions? Somebody raise a hand there.
Hi.
Hi.
I really enjoy your lecture. It was very interesting, and I have some question about the inversion dependency.
Mm-hmm.
So from what I understand, one of the concepts of inversion dependency is to make a layer between our code and the third-party framework we want to use, to implement our requirements to the framework.
Basically,
to any
yes.
one framework.
Mm-hmm.
So we can implement it. So if we want to migrate to another, we just fulfill these requirements with the new third-party framework.
Right, and this perfectly describes it, and this only works if your business defines the requirements. Otherwise, you'll just find yourself sort of duplicating the framework's APIs to create an abstraction layer. That's worthless. That's the wrong approach, right? Your business needs to define the requirements, and you need to be in charge of the API, of the interfaces.
Yes, thank you.
Okay, so any other questions, guys? Okay, then, in such case, thank you. Oh, there's someone in the back there.
Hi, I really enjoyed the lecture, but I do have one question, and it's more about infrastructure development, not business code development, but infrastructure like frameworks, etc. So basically, in this particular case, when people are using third-party libraries, not frameworks, but libraries, you pay a lot of price for the thick anti-corruption layers that actually go around those libraries. Can you make a suggestion of how that can be fixed? I mean, a good practice in this scenario.
So here is what I have observed in quite a few cases. Let me give you a real-life example. I was recently working with a team where we had a service that was basically the checkout of an e-commerce site, and you know that the checkout, it technically just it creates like a quote or an order that it basically passes off to SAP. So, and the question was, how do we achieve persistent in that checkout module, if you want? And we discussed a few possibilities and then ended up with the idea of, you know, let's just serialize the PHP objects. That's one line. Let's unserialize them if we need them again. That sounds like a really crappy solution, but in fact, in that case, I'm pretty confident it's going to hold for a long time. So what I'm suggesting is, as you define the interface, oh, I need something to persist, a checkout object or a cart object, right? If that doesn't have to live long, if people don't have to access that for whatever means, you may get away with a very, very, very simple implementation. Go ahead, it's just 1 hour, create it, right? Maybe it's throwaway code. Maybe in 1 year you're going to say, you know what, our persistence implementation is not sufficient anymore. We need to throw it out of the door, but honestly, it took us 1 hour to write it. It's going to take you 1 hour to download Doctrine and understand the documentation of how to get started. So what is the quicker solution, right? So in essence, what I'm suggesting is, and that's a very good question that you've asked, does it even pay off using a third-party component? If I only have some little things that I need to do, I would always suggest write them in the first place. If at some point you realize that your solution doesn't work, well, you have loose coupling, you have dependency inversion. If you do it right, you can always swap it out and then bring in other components. It's too much thinking about technology, is which framework are we going to choose? The same thing goes for, okay, which components do we need? I was recently working with a team. They showed me a Symfony 2 project for REST API, and some of the standard modules they had was like stuff to compress CSS and JavaScript. And I went like, okay, so why exactly do you need that for a REST API? And I said, yeah, maybe we should remove it. Okay, thanks, guys.
Velmi to say.